Today we're going to look at solving equations in a variety of different types of problems where we have one variable. General idea is isolate all the variables to one side, all the constants to another. Finally, once you combine like terms, divide by the coefficient in front of the variable and your problem is solved. So let's start this and we'll distribute the 3 to the two terms. We get 6x plus 15 plus 7x equals 9 plus 3x. Combine like terms, giving me 13x plus 15 equals 9 plus 3x. Isolate the variables to one side, so I'll subtract 3x to both sides. And then get the constants to the other side. Subtract 15 to both sides, leaving me with 10x equals negative 6. Divide by the coefficient of 10, both sides. Reduce any fractions that are left, and get negative 3/5. In our next example, we'll take and notice that we have a fraction. And whenever I have fractions, I'm not super comfortable in dealing with them, but what I'll try to do is I'll try to clear my fractions, and the idea behind that is find the common denominator of each term on all sides and multiply by that common denominator. So in this case, I have a denominator of 3 for the first term, 1 on the second term, and 1 on the third term, thus giving me an LCD of 3. If I distribute that to all three terms, even though this is very complicated, it's still one fraction, so it's one term. This is another term. And finally, we have the third term over here. Multiplying 3 over 3, that gets me a 1. That's like the multiplicative inverse. So that's 6 minus 2 times the quantity of x minus 4 minus 6x, because that's 3 times 2x. So this is popping up. And then equals 24. I distribute through, I have 6 minus 2x plus 8 minus 6x equals 24. Combine like terms, I have 14 minus 8x equals 24. Isolate the variable terms, subtracting 14 to both sides, giving me negative 8x equals 10. Divide by the coefficient, and x is equivalent to negative 5/4.
So in this case we have a number of different fractions, and again we're going to try to clear those fractions, but first I like to distribute any terms that need to be distributed. So in this case I have 3/4 x plus 15 over 4 plus 5 over 2 equals 1/6 x plus 3/5. And to clear the fraction, I need to look all the way across both sides at all those denominators and find a value that is the lowest common denominator of each of these denominators. So if I look at 4, 2, 6, and 5, I'm going to go with 60 as my LCD, and I will distribute that term to each and every term across the equation. Notice this 60 and 4 reduced to a 15, so that's 15 times 3x, the 4 reduced once again. Again, I have the 60 and the 4 reducing to 15, so that's 15 times 15. The 60 and the 2 reduced to a 30 times 5. The 60 and the 6 reduced to a 10 times x, and the 60 and the 5 reduced to a 12 times 3. Cleaning all that up, I have 45x 15 squared, I believe, is 225. Plus 150 equals 10x plus 36. I'll combine like terms, so I have 45x. 225 and 150 is 375 equals 10x plus 36. Going to subtract 10 from both sides. And I'm going to subtract 375 from both sides. 45 minus 10 gives me 35x. And on this side I get negative 339. Divide both sides by 35 and x equals negative 339 over 35.
So in this case, we have a number of different groupings. I like to work with the innermost grouping first, whenever possible. So I have 5 minus the quantity of 3 plus, I'll distribute this 2 through, 2x plus 14 is equal to 2x minus 12 plus 12x. Combine like terms in the parentheses. So I have 5 minus 17 minus 2x, plus 2x is equal to 2x minus 12 plus 12x. So in this case, you'll notice there's a subtraction of this whole term, which basically means go ahead and distribute that negative through to both terms. And in doing so, we end up with 5 minus 17 minus 2x equals 2x minus 12 plus 12x. Combine like terms on each side. I have negative 12 minus 2x equals 14x minus 12. Notice in this case, I'll combine any like terms, which I've already done, and then I'll group and try to get all my variables to one side of the equation. So in this case, I add 2x to both sides, and then I'll take and add 12 to both sides, and we get something kind of special going on here. On the cursor, we get 0 on one side of the equation, and on the other side of the equation we end up with 16x. Divide that coefficient just like we've been doing throughout, and we end up with x equaling 0, which is a fine answer. So literal equations are basically multivariable equations where you're solving for a variable rather than looking for a numerical answer. We're going to get an expression as our answer. So in this case, they want us to isolate the variable z. So to do that, I'm going to take and distribute my b through, giving me a equals bc minus bz minus d. I want to get my z term isolated on one side of the equation, so I'll subtract bc, add d to both sides. Notice there's no like terms there, so I have a plus d minus bc equals negative bz. If I divide both sides by negative b, I end up with the following term on this left. Typically, Publishers don't leave negatives in our denominator. So what we'll do is we'll just divide a -1 into each of these terms, and that will be my answer. I have negative A minus D plus BC over B is equal to quantity Z. And thus I've solved my literal equation for the variable Z. Let's do the same thing. This case, you'll notice my variable that I want to isolate is on the denominator. We need to get that to the numerator. So it's just like clearing a fraction. Multiply by your common denominator to both sides. Notice W minus Z times W minus Z reduces to 1, so I have 2BC, or B plus C, sorry, is equal to A times W minus Z. I'll distribute the A in, getting 2B plus C is equal to AW minus AZ. Subtract AW to both sides, 2B plus C minus AW is equal to negative AZ. And I want to isolate once again my Z term. So in this case, I'll divide by negative A to both sides, and just like last time, don't want to leave a negative in the denominator, so divide by -1 to each term, getting negative 2B minus C plus AW over A. Notice these A's will not reduce because I can't reduce across addition and subtraction. We learned that freshman year. So here's a couple literal equations, one for surface area of a cylinder, one for volume of a cylinder. And the problem asks us to write an equation for the volume in terms of the radius and the surface area. So what the heck does that mean? It means basically we're going to take and solve for V so that I only have R and H in my answer. The problem with this is the following. In my V equation currently, there's my R, but I have this H, and I have to get rid of H so that H only has R's and surface areas in it. Well, in order to do that, I'm going to have to use this top equation and then substitute into the bottom equation. So let's do that. Let's get H by itself in my surface area equation. So for my surface area, we notice that we have surface area equals 2 pi r squared plus 2 pi h. I want to get h by itself. So I'll subtract the 2 pi r squared to both sides of the equation, giving me surface area minus 2 pi r squared equals 2 pi h. Now I need to isolate h, get it by itself, so I'll divide both sides by 2 pi. Thus, I've got h equaling the surface area minus 2 pi r squared over 2 pi. Now, the problem's not done because initially we were asked to write the equation for volume in terms of my radius and my surface area. Well, here's my volume equation. I have volume equals pi r squared and h. But h now is expressed as the surface area minus 2 pi r squared over 2 pi. So I'm going to make that substitution here and say that I have surface area minus 2 pi r squared over 2 pi, and that is my h value. So notice my volume is now expressed in terms of surface area and radius. The only thing I have to do is clean this up a little bit. I notice now that here's a multiplication, so I can do some reduction. I can reduce this pi with this pi here because it's a multiplicative property. So I have r squared times my surface area minus 2 pi r squared all over, since the pi is reduced, 2. And so now my volume has been written in terms of r's and surface areas. And I'm done. So next we're going to write some algebraic expressions to represent verbal expressions. So this is just changing words to variables and numbers. Product is a key word here. Square is a key word. Less is a word. So product of 17 means 17 times something. And the square of 7 less than w. Well, 7 less than w, 7 less means subtract 7 than w, and I'm taking the square of that. So that's how I rewrite that verbal expression. In this next example, I take the sum of, which is a key word, multiplied, there's another key word, difference is another key word. So we're taking the sum of a number p, so it's p plus, and 11, and we're going to take that sum and multiply it by the difference of q, that's the first term, and 14 is the second term. That's all we've got today. Do the problems assigned for lesson 2 and fill out your summary form, and we'll get back to you tomorrow.